calculate the support reaction. But before then, this topic is under equilibrium of forces. This type of force, it is called non-coplanar concurrent force. Basically, there are just three. We have the coplanar force, non-coplanar force, and collinear force. Now, under coplanar force, we have concurrent force, non-concurrent force, and parallel force. Similarly, for non-coplanar force, we have concurrent, non-concurrent, and parallel. But we'll see this later, maybe in another video, the introductory video. But for today's class, we want to solve this question. So what it means is that for each type of force, you'll be given a force system under it. You will now solve. So for this particular one, the type of force it is non-coplanar concurrent force system. But we are just interested in knowing the value of the support reaction. Now, check this guy here. Before then, I'll use what we are familiar with to explain. From our idea of physics, from the practical aspect, there's this experiment we do then, equilibrium of forces, right? Where we make use of our ruler and pivot. Is that true? Our ruler and our pivot. You plot the graph. Masses. The pivot and the ruler will be loaded with masses. That we are doing a similar thing here too. But what we are doing here is that those pivots is referred to as support here. Those pivots or pivot, it is referred to as what? Support. While that ruler, it is referred to as beam. Then those masses that we loaded our ruler with is referred to as load. So meaning, as far as this question is concerned, basically we have three terms. The first one is what? Beam. Second one is what? Load. And the third one is support. But for our level, we don't need to bother ourselves with those definitions. Beam, you will see what a beam means later on. So from here, first thing first, when you want to solve question like this, there's what we call free body diagram. There's what we call free body diagram. Solution, free body diagram. By free body diagram, what it means is that, look at this question given. This question, by free body diagram, how many forces do you have there? When I say force, I mean your load and your support. That masses that we know is what we call load here. All these guys here, they are the masses we are familiar with. But in this context, we are using what? Load. That pivot, these are the pivots now. They are called support. Then this line that I are seeing is the ruler, which is beam now. So my question is, check this guy here. How many forces do we have here? 5. This is the first one, second one, third one, fourth one, and fifth one. Your load and your support are considered as your what? Load. If I'm telling you that we have more than 5 forces, is that correct? Visually, what we are seeing here is what? 5. This first one, second one, third one, fourth one, fifth one. But me not telling you that we have more than 5 here. What does it mean? It means we have hidden force in this structure. True or false? True. So how do we see these hidden forces with free body diagram? So by definition, take down, what does free body diagram mean? Free body diagram is a diagram that shows the hidden force in a structural system. Free body diagram is a diagram that shows the hidden force in a structural system. From here, we said we've listed out some terms, right? The first one is what? Support, which is our pivot that we are familiar with. Now, our load, which is our what? Masses. Then, my beam, which is your what? Ruler. Right? Now, let's take the first one, support. When it comes to support, we have 3 types of support. We have what? 3 types of support. The first one is what? Support. Take note, your support has its respective reaction. Meaning for every support, they have their own respective reaction. The first support is pin support. When you have something like this is a pin support. Number 2, roller support. When you have something like this is a roller support. Number 3, fixed support. When you have something like this is a fixed support. So what it means is that for fixed support, there's a reaction. Roller support, there's a reaction. Fixed support, there's a reaction. But for our level now, we are limited to pin support and roller support. What that means is that for any question given to you, you can't see fixed support here. You only see pin support or roller support. Now check this beam. From what we've explained here, what type of support do you have here? You have the pin and roller. At what point do you have roller, and at what point do you have pin? At point A, you have the roller. At point B, you have the pin. Now let's look at the reaction one by one. For the pin support, the reaction is vertical reaction and horizontal reaction. For your roller support, vertical reaction. For fixed support, it has vertical, horizontal, and a movement at that point. But just you are interested in these two guys and not this last one, because for our level you are meant to know these first two. But just take note of this as well. All right, moving on. We said we look at what we call support. Now let's take the next one, load. Under load, we have different type of load. We have point load and we have a UDL. We will come back to this. Your point load is in this manner, then the unit is kilonewton, then the unit of this guy is kilonewton per meter. Just take note of this. Take note of this load, this point load and UDL. You will see how it works. You get? Just take note of it. We'll come back to it. Now, uniformly distributed load, yes. First thing first, from here, we've seen support and its reaction. We've seen load, right? But this guy here, you want to know the reaction at point A and at point B. Earlier I said this topic is under what? Equilibrium. The word equilibrium, what does it mean? Balance, a state of balance. A state of what? Balance. Meaning the net force acting upward must be equal to the what? Net force acting downward. Let's say you have this guy here. Let's say this is your beam. This is your beam. I'm holding this beam. Identify. I have a support and I have a body here, which is a beam. True or false? What's your beam? What's your support? Using this analogy, my hand is the support, this carton is the what? Beam. For this guy to be in a state of equilibrium, it means the magnitude of my hand is equal to the magnitude of this carton, which is the beam here. So that's what we are saying by the word equilibrium. It means the net force acting upward is equal to the net force acting downward. So what it means is that you'll be considering, to get this support reaction, you are considering the conditions of equilibrium, and there are just three. Summation of f of y is equals to 0, summation of f of x equals to 0, and summation of movement about any point equals to 0. But before then, we are discussing free body diagram, right? Now, in place of this guy, this support, substitute their respective reaction. In place of what? This support, substitute the respective reaction. Meaning, drawing your diagram, you know the purpose of free body diagram, showing the hidden force in a what? Structural system. Now, you are repeating everything, but in place of roller support, you have this guy. In place of pin support, you have this guy. Is that understood? Now, let's do that together. We've done that and we got this. Now, from here, this is the initial question, and this is the question after considering the free body diagram. Now, with this free body diagram, you will see that you have 6 forces, right? How are you able to know that you have 6 forces? With the help of this free body diagram, you identify that you have what? 6 forces. So that's how it works. Now let's apply the first condition, condition 1, condition 2, and condition 3. For the first one, before applying the first one, let's relate it to what we know. You know, from your Cartesian coordinate, this is your x-axis, this is your what? Y-axis. This is the positive region, this is the negative region, positive region, negative region. Now let me do something like this. From here, what it means is that when considering f of y, force of this nature positive, force of this nature negative. When considering f of x, force of this nature positive, force of this nature negative. Is that understood? Yes. We are using the idea of Cartesian coordinates. So implementing that idea, it becomes what? Summation f of y equals 0. Force of this nature positive, force of this nature negative. Now check. Using the free body diagram, how many forces do you have in total? In general? You have 6. You have, how many vertical forces do you have? How many forces of this nature do you have? We have 5. 1, 2, 3, 4, 5. You know, this is an inclined force. This inclined force, you can solve it to the vertical axis, also to the horizontal axis. When you are considering vertical, you need this inclined in vertical. When you are considering horizontal, you need this inclined in horizontal. Meaning, let's solve, before considering this condition, let's resolve our inclined force. So considering joint E, meaning this is E, right? This is the force, 25 kilonewton. This is 42 degrees. So we want to solve for f of y and f of x. Now, for f of y, that will be what? You are solving this force to the vertical axis. That will be what? This angle, where is it inclined to? Vertical or horizontal? Horizontal. Because it is inclined to the horizontal. Horizontal component takes what? Cos. While vertical takes what? Sin. Now, vertical becomes what? 25 sin 42 degree. But what will be the sign? Is it positive or negative? The idea is simple. Negative. This arrow, tip it to the vertical axis. Since you are solving for vertical, tip it to the vertical axis. The force, will it be facing down or up? Down. Check here. From your Cartesian coordinates, let's say this is your axis. You know, this is the negative side, positive side, negative side. Since the force is facing down, meaning negative. Use that same idea. F of x should be what? 25 cos 42 degree. Positive or negative? Why positive? Because by the time you tip this force to the horizontal axis, is it facing the positive region or negative region? Positive region. So it becomes positive. So what's the answer? Your answer for f of y is what? 16.728 kilonewton. F of x is what? 18.579 kilonewton. Meaning, come back to your free body diagram. In place of this inclined force, what do you have? You have a vertical force, which the value is what? Negative, not just 16, negative 16.728. And you have an horizontal force, which is what? 18.579. So let's substitute that. So meaning from here, let's say this is point E. On point E, you have a vertical force, and the value of this vertical force is what? 16.728 kilonewton. Will it still be minus? No, because this arrow it has signified that the force is acting downward. You get? Then that's on point E. On point E, you now have two forces, the vertical and the what? Horizontal. This is the vertical. Then for the horizontal, the magnitude is what? 18.579 kilonewton. All right. 18.579 kilonewton and 16.728 kilonewton. So let's apply this condition. For the first one, first acting like this, positive. First acting like this, negative. Now check. Let's apply. That will be what? RA is acting upward. True or false? Plus RBY acting upward. Continue. Negative what? 7 minus 15 minus what?
16.728.
16.728. Are we done with all the forces?
Yes.
I mean the vertical forces. Are we done with it?
Yes.
Equal to 0. Is that all?
Yes.
This is wrong. When we are considering this summation, f of y equals to 0, meaning force. What's the unit of force? Force is measured in what? Kilonewton or Newton. In this case, they are using kilonewton, meaning my force now is what? Kilonewton. But check your 7 kilonewton. Check this 7. What's the unit? Kilonewton per meter. So what that means is that this type of force is called a UDL, uniformly distributed load. You know, earlier we said we have different type of load. We have point load. What's the unit for point load? Kilonewton. What's the unit for UDL? Kilonewton per meter. So you are converting kilonewton per meter to kilonewton, meaning converting a UDL to a point load. Converting a UDL to a point load. Now take down. Right, UDL. UDL. There we have point, or you say fact, to know about UDL. For UDL, a UDL meaning uniformly distributed load. The first point is that the distance of a UDL acts at the midpoint. Converting a UDL to a point load, converting a UDL to a point load, simply multiply the intensity of the UDL by the total distance it covered. Simply multiply the intensity of the UDL by the total distance it covered. So what we are saying is that this is a UDL. Your UDL will be given as this. Or this. This is a UDL. And the intensity is what? W kilonewton per meter. This is what? W kilonewton per meter. W kilonewton per meter. Right? Now, let's explain the first point. Let's explain what we've stated for UDL. Let's explain the first one and the second one. Now, let's say this UDL. This is A, this is B. The total length of this UDL, let's say the total length is L meter. Number one, the distance of this UDL. Read what you have in your notes.
The distance of the UDL acts at the midpoint.
The distance of a UDL acts at the midpoint. So check this UDL. What's the distance? L over 2. How do you get L over 2? If the total length is L, then the actual distance is what? L over 2. Meaning L multiplied by 1 over 2. So what we are saying in essence is that if your UDL is 8, the distance is what? 4. Meaning any length you are seeing for your UDL, the actual distance is half of that length. Visually, I'm seeing L, but that's not the actual length. The actual length is what? Half of L. You get the logic? What if your UDL, this is 9 meter, then the actual length will be what? 4.5. 4.5, meaning 9 over 2, you have 4.5 meter. That's number one. Number two, read the number 2. What do you have? Converting a UDL to a point load, multiply the intensity of the UDL by the total distance it covered. When we say intensity, it means magnitude. Now, what's the magnitude of this UDL? W kilonewton per meter. Meaning W kilonewton per meter times what's the total distance? L meaning multiply by L meter. Observe, meter cancel meter. What do you have? L kilonewton. Now, initially, my UDL is measured in what? Kilonewton per meter. Now, check. Your UDL is measured in what? Kilonewton. What you did here, you've converted your UDL to a point load. Meaning, you join this diagram. This is what you have. A, B, L, point load. WL kilonewton. Call this one, call this 2. 1 and 2, are they the same? 1 and 2, are they the same? Yes. 1, you have a UDL. 2, you have a point load. But you've converted this UDL to a point load by multiplying the total intensity, which is this, times the distance. Because this is what this is the unit acceptable when you are considering summation f of y and not kilonewton per meter. You get what I'm saying? Now, for this given question, stylishly, this guy, what type of load is this? Yeah, UDL, a uniform distributed load. But indirectly, it was given like this. It was given as point load. Meaning, the question wants to test your smartness. So this is a uniformly distributed load. So what I'm supposed to have here is this guy. And what's the intensity? 7 kilonewton per meter. You understand? You understand? Yes. This is what I'm supposed to have here. And the intensity is what? 7 kilonewton per meter. From this given question, this is what I'm expecting. 7 kilonewton per meter. First, because don't forget these two facts. Number one, getting the actual length of a UDL. It acts at the what? Midpoint. Number two, converting your UDL to a point load. What do you have? The intensity times the total distance the UDL cover. Now let's apply the first condition of equilibrium. And the first condition is what? Summation f of y is equals to 0. Upward force positive, downward force negative. Come back to this beam. How many forces do you have? How many vertical force do you have? How many force of this nature do you have? 5. 1, 2. You can convert this here, right? Yes. 3. This one 4, and this guy 5. Let's take it one by one. RAY plus RBY negative 15 negative 16.728. Convert your UDL to a point load. That will be what? Check number 2 facts about UDL. Converting UDL to a point load. What will you do? Check your book.
You divide the distance of the point. That is 7 times.
Like this. Now, you know what we want to do here? We want to convert this UDL to a point load. You know, me writing 7 kilonewton per meter there, you know why it is wrong? Yes. Because that's not the unit of force. Now, how do we do that? How do we achieve it? Convert this 7 kilonewton per meter to a UDL. Now, check the two statements there. Converting a UDL to a point load. How do you go about it? Simply multiply the intensity of the UDL by the total distance the UDL covered. Now check, what's the intensity of this UDL? 7. What's the total distance it covered? 2.5. So what are you saying? 7 times 2.5 equals to 0. And that's it. Do you understand? Do you understand?
For the first condition, it says
that one, no, we said first condition, the distance of a UDL acts at the midpoint.
yes.
The distance of a UDL acts at the midpoint, right?
Yes.
But here, number 2, converting a UDL to a point load, the intensity of the UDL multiplied by the total distance the UDL cover. We are not saying multiply by the distance of the UDL. We are saying multiply by the total distance the UDL cover. Hope you are getting it.
Yes.
Are you getting it?
Yes.
Number 2, the intensity of the UDL multiplied by the total distance the EDL cover and not the distance of the EDL itself. If it is the distance of the EDL itself, it will be what? 7 times 2.5 over 2. Yes or no?
Yes.
Yes. But you are saying the intensity multiplied by the total distance the EDL cover. You now get. So let's solve this guy. Meaning R AY plus RBY negative 15 negative 16.728 negative what this 17.5 equate to 0, meaning RAY plus RBY, sum this up going to the other side, 49.228 kilonewton. Call this equation 1. This is the first condition. Summation f of y equals 0. We got this equation. Now summation f of x equals to 0. Any force of this nature positive, force of this nature negative. Now check your beam. How many force of this nature do you have? 2. And they are what? RBX and 18.579. So RBX, will it be positive or negative? Negative RBX. This one positive or negative? Negative what? 18.579 equals to 0, meaning RBX is equals to what? Negative 18.579 kilonewton. Is that correct? By the time you get negative, it is only telling you that what you've assumed here for RBX is the opposite, meaning this is what you are meant to have for RBX. So having a negative answer does not mean anything. Just know that either RBX or this force, the initial assumption that you made is opposite of it. You know, if from here, if this was my assumption initially, RBX here takes what? Positive. So being positive, by the time this one go to the other side, I have a positive answer. So getting a negative answer, positive answer, you are interested in the magnitude and not the nature of force. If you get negative, meaning your assumption from here is the opposite. So this is your answer. 18.579 is your answer. Out of these 3 support reactions, you've solved for what? RBX. You are yet to know what? RAY and RBY. Now let's apply the third condition. Now, taking moment about point A. Now when it comes to moment, the idea is very simple. This you're giving me. Observe, when you have a support reaction, you have your support reaction at point A and at point B. So when taking moment, what it means is that you can only take moment at the point where you have your support reaction. From here, looking at this B, you have your support reaction at A and at point B. If you take moment about point A or point B, you still get the same answer. But when it comes to moment, what you should put into consideration when it comes to sign convention, for your sign convention, it is when you are going in a clockwise direction, take it as positive. When you are going in an anti-clockwise direction, take it as negative. Now, how do you identify your clockwise and anti-clockwise? Here is how it works. If you are going in the direction of your clock, your direction of your wall clock, it becomes clockwise, meaning positive. If you are going against the direction, meaning anti-clockwise. So from here, I'll be taking moment about point A. When you are taking moment about point A, right, summation of moment about point A equals 0. What if I'm taking moment about point B? It becomes summation of moment about point B is equals to 0. But for this question, I'll be taking moment about point A. You can use same idea to take moment about point B. You will definitely get the same thing. Alright, moving on. Taking moment about point A. Mathematically, what is moment? Moment is equals to the force and the perpendicular distance. Meaning, each force is here. You are traveling to point A. And these forces have their respective distance they cover. But the nature of the force you should consider should be vertical force. Meaning, any vertical force, you know, from here you have vertical force and you have horizontal force. The moment of this force on point E, moment of this force on point B, moment of this force on point D, of course, the moment of this UDL. You already know how a UDA works. We stated it. We said number one point of a UDA, converting a UDA to a point load and knowing the actual distance of the UDA. We will implement that here. Alright. Now let's take our moment. Taking moment about point A. Let's consider these forces, then we consider our UDA last. The 15 kilonewton is traveling to point A. Identify in what direction is it going. Is it clockwise or anti-clockwise? If it is clockwise, it takes positive. Anti-clockwise, it takes negative. This is it. Now, imagine you are taking the tip of this force to A, meaning you are going in this direction. You are going in this direction. You are going like this, because you are going like this, and if you are going like this, is it going in the direction of your work log or against it? It is going in the direction, so it becomes positive. So positive meaning positive clockwise. Only two brackets. What's the force? Moment means force times the perpendicular distance. What's the force? 15. What's the distance? 15 covered. 1.5. Right? On to the next one. RBY. We said consider the force of this nature, meaning only vertical forces. So RBY is going. In what direction is RBY going? Is it going in a clockwise direction or anti-clockwise direction? Observe. RBY is going in this manner. It's going in this manner. Meaning you are taking the tip of RBY to point A. That's how it works. If you are taking moment about a particular point, meaning you are taking the tip of other forces to that point. Now, take the tip of RBY to point A, meaning you are dragging it like this. And of course, it is going against the direction of your work log. So it takes negative. Negative all into brackets. RBY times the distance RBY covered. 2.5 plus 1.5. Before getting to point A, summation of 2.5 and 1.5, that's what? 4. On to the next one. We have this man here, 16.728. 16.728 in what direction? Is it going in the clockwise direction or anti-clockwise direction? If it is going in clockwise, positive, anti-clockwise, negative. Now check, in what direction? Clockwise. It is going in the direction of your clock. Positive all into bracket 16.728 multiplied by what the total distance before getting to point A. 2 plus 2.5, 4.5 plus 1.5, that was 6 meters. So multiply by 6. We are done with these forces. Then the last one, we have this CDA. How does this CDA works? Yeah, very simple. To get the moment of this CDA, you need the force and you need the distance. Yes, that it works. From here, you need the force of your UDA. How do you convert your UDA to a force? Meaning, when we say force, it simply means point load. How do you convert your UDA to a point load? Check the number 2 statement. It said, simply multiply the total distance the UDA covered by the intensity. Meaning, in this case, the intensity is what? Let's solve for the UDA. UDA. What's the intensity of this UDA? What's the intensity of this UDA? 7 kilonewton. 7 kilonewton per meter. Right? What's the total distance it's covered? Multiplied by 2.5 meter. Then you notice that meter cancel meter. We solved this earlier. And the product of this gave us 7.5 kilonewton. Right? Now, this is just the force of this CDA. To get the moment of this CDA, you need the force and you need the distance. Now, how do you get the distance? Earlier, I said the actual distance of a UDA acts at the midpoint. Now, from this given question, we have that the length of this CDA is what? 2.5. Then the actual distance becomes what? 1 over 2 times 2.5. Meaning distance of your UDA 1 over 2 times 2.5, and this is equals to 1.25 meter. So what this means is that computing the value of moment for this CDA, it means the product of 17.5 kilonewton and 1.25 meter, and you get your moment. So in place of the moment of the UDA, you have 17.5 times 1.25. But the question is, this UDA, is it going in clockwise direction or anti-clockwise direction? Now, check this beam. This beam, your UDA is spanning from C to A, and you are taking moment about point A. The direction, we simply start from C, meaning you are going from C up to A. Then this is how you are going. You are going in this manner. Let's say you are tipping your UDM to point A. In what direction? Is it going in the clockwise or anti-clockwise? It is going like this, meaning it is going against the direction of your work clock. It takes negative. For your UDM, you have negative all into brackets, the force, which is 17.5 times the distance, 1.25. We know how we got the force and the distance. Then ask yourself, are we done taking the moment of all the forces? If yes, equate to 0. So you are equating this to 0. So now from here, you will notice that you have RBY, which is the only unknown here. So make RBY the subject of the formula. 22.5 minus 4RBY plus 100.368 minus 21.875 equals to 0. Now, take RBY to the other side, meaning 22.5 plus 100.368 negative 21.875 is equals to 4 RBY. Input this in your calculator. What do you have? Yeah, I'm having 100.993, meaning 100.993 is equals to 4 RBY. Of course, divide both sides by 4. That is RBY. Therefore, RBY, by the time we divide this, what's the answer? 25.25 kilonewton. Meaning that we've gotten RBY to be 25.25 kilonewton, right? The third unknown, how do we get RAY? Go back to equation 1. From equation 1, we have that RAY plus RBY is equals to 49.228 kilonewton, right? Now from here, see, let's substitute the value of RBY which we got, meaning RAY plus 25.25 equals to 49.228 kilonewton. Make RAY the subject of the formula. That is, RAY is equals to 49.228 minus 25. By the time we subtract this, what do you have? 23.98 kilonewton. Meaning RAY is equals to 23.98 kilonewton. So go back to your beam. Substitute the value of RAY to be what? 23.98 kilonewton, and RBY 25.25 kilonewton. Right now, earlier when we discussed equilibrium, we defined the word equilibrium. We said before this beam can be in equilibrium, the net force acting upward must be equal to the net force acting downward. Meaning, if the net force acting upward is equal to the net force acting downward, then this beam is in a state of equilibrium, a state of balance. Now, how do we check? So we are saying summation f of y, meaning the summation of vertical forces acting upward is equals to the summation of vertical forces acting downward. Now, this is how to confirm. From here, these are your downward forces and this is your upward force, right? Your downward force, we've converted this UDL to a point load, meaning to a force, and we got 17.5 kilonewton. 15 giving 16.728, our inclined force that we resolve vertical. This is what we got. Now, input this in your calculator: 17.5, 15, and 16.728. Your answer must be this. By the time you solve that, by the time you input that, you have 49.228 kilonewton. Approximately, let's say 49.23 kilonewton. Then of course, we've seen from equation 1 that RAY, which is this, and RBY, which is this, is equals to what? 49.228 kilonewton. So in conclusion, what this means is that before this beam can be in a state of equilibrium, meaning a state of balance, the magnitude of ray must be 23.98. Then the magnitude of rby must be 25.25. In a case whereby we just did an assumption, let's say okay, you are putting 20 here, 20 kilonewton, and in this case we are putting 29.23 kilonewton. The idea, using that same idea, it is still correct, right? Because the upward forces are equal to the downward force. But in this case, the magnitude of ray and the magnitude of rby, they are wrong. In advanced class, this beam will collapse. This beam will collapse in advanced class, meaning when you are doing strength of material and theory of structure, there are courses like that. We will look into more of this then. But for your level, giving a question, precisely you are giving a question like this under a beam, equilibrium of forces. To know if your beam is in equilibrium, you apply the conditions of equilibrium, which are summation f of y equals 0, summation f of x equals 0, and summation of the moment about any point equals 0. So I would love you to try the moment. Take your moment about point B and see what you get. We took moment about point A, we got our answer. I would love you to try this on your own. Take moment about point B and let me know your answer in the description below if you get the same thing or not. Alright, right. Therefore, ray is equals to 23.98 kilonewton, rby is equals to 25.25 kilonewton, and lastly the value of our rbx 18.58 kilonewton approximately. Alright, this comes to the end of this video. If you find this video interesting, do well to share your thoughts in the comment section. See you in the next video.